Okay, so for part B, same idea. We want to look for our W. If we can spot our W, we can substitute it out. We also have to make sure that we not only get rid of K's, but get rid of DK's. So we need to switch to DW's if we're going to switch to W's. Okay, so again, the things you're looking for. One is a function and its derivative both appear. Two is W is going to be the inner function in some composition. So here, the first thing that jumps out at me, uh-oh, no pen working, hold on. Okay, this is definitely composition. This is e to the stuff composed with a 1 over k. If my W should be the 1 over k, I want to think about the derivative of this. So the derivative of k to the negative 1 is negative k to the negative 2, which actually makes me really happy to see this k squared in the denominator. So I'm liking my odds of picking this. I should say these videos are going to be a little misleading in that I'm pretty good at picking my W's, so you're not going to see me guess and check a lot. The truth is, when you're doing this, you're going to have some trial and error. You're not going to learn from this if you don't make some wrong guesses and see what happens. So if I remember, I will try and show you a wrong guess somewhere along the way when one jumps out as being an obvious thing that people will do. But just be aware that you're going to try, you're going to see what happens, you'll know you've messed up if you can't get rid of all the K's and the DK. Okay, so I'm going to try this. And remember, we're taking derivatives, not antiderivatives. This is something that gets really hard in Calc 2, is going back and forth a lot. So I want to take the derivative of W with respect to K. And this is somewhere people get a little funny with this, like what is actually happening? And the notation says exactly what's happening. I have defined my W of K function. So I'm not writing it this way, but this is what I'm saying. I'm going to say I am naming W, which is some function of K. So if I want to take the derivative of that function with respect to K, it's called a dW dk, and it's equal to negative 1 over K squared. So we said we have K to the negative 1, its derivative is negative K to the negative 2. Now I want to use this to try and get rid of dk's. So I'm going to move the dk up and say negative dk over K squared is the same as a dW, which I really like because here's my my dk over K squared. You can move that dk in and out of the top of the fraction whenever you want. But I don't have the minus sign, so I'm going to go ahead and multiply both sides by negative 1 and move that over. Which means my integral turns into an e to the w, and my dk over K squared turns into a negative dw. Make sure you're really clear that this is a times. This isn't e to the w minus dw. In fact, I'd be kind of unhappy if that's what it was. So really, this is an opposite of the integral of e to the w dw. Okay, so what we've just done is completely hidden that inner function, the W of K function. We're just calling it W, and now we can focus on the f of x function, the f of W function, which is e to the W. That's a really simple one to integrate. So now we can say we've isolated our outer function. We know that the antiderivative of our outer function is still e to the W. That minus carries through, and I need to throw a plus c on. And again, a lot of people will space out and forget here. A lot of people will also forget their plus c. Don't do those things. If we are looking for the antiderivative of e to the 1 over k divided by k squared, we are not done if our variable is w. So final step is this. And I didn't show it in the last problem, but again, a really good way to learn this process and make sure you're getting it. I had an orange I was really liking. Is it that guy? That guy? Okay. Is to check. And the way that you check, whoa, that does not look like the word check. Check, still doesn't, oh well, is by taking the derivative. So the derivative of e to the stuff is e to the stuff The negative sign just carries through when we take the derivative. The chain rule says you'd multiply by the derivative of the stuff. Remember, that's a k to the negative 1, so we're going to get a negative k to the negative 2. The derivative of c is 0. Notice that our signs cancel out, so I have e to the 1 over k divided by k squared. Perfect! That's exactly what I wanted. So this is, in fact, my antiderivative.